known as torrential event. The monitoring of river discharge is vital for management of water resources, water balance, evaluating the basin scale of validation for hydrological models. Therefore, it is essential to understand a model which is capable of identifying the source of base flow in addition to quantification of amount of base river flow. Now, with this thought, I would like to invite Dr. Varun Narayan Mishra, Assistant Professor at Center for Climate Change and Water Research, to take forward today's event with a welcome address. Sir, please.
Yeah, yes. Thanks, Priyanka. Thanks. A very good afternoon to all of you. I hope all of you will be in good health and safe in this tough time. I, Dr. Varun Narayan Mishra, working here as assistant professor, welcome our today's eminent speaker, Dr. Bojan Đurin from Croatia, all the participants and attendees who are present here in the webinar on the title of Flow Analysis of Torrential Rivers, a case study of Croatia. First of all, I would like to briefly describe our center and our university on this occasion. Our center, that is Center for Climate Change and Water Research, is a research-driven academic center established at Suresh Gyan Vihar University, Jaipur. Our center runs a UG course, that is BSc Honors in Geology, and we have also offering 2 PG courses, that is MSc in Geoinformatics and MTech in Geoinformatics. We also offer doctoral degree in geoinformatics and its application and sustainable development practices. Our center is extensively involved in the research and development in the field of remote sensing and GIS, with its various applications in geography, forestry, environmental science, urban planning, climate change, natural resource management, and other allied disciplines. Over the last few years, we have published several research papers in international journals of repute and published many edited books with international publication houses like Wiley, Springer, Taylor and Francis, etc. As the topic of today's webinar is quite interesting and innovative, so I hope it will bring new research ideas and dimension in the field of river flow dynamics, hydrological modeling, and water resource management that will be very much helpful for future studies related to the flow, river flow, and other water-related studies. So, on this note, now I would like to call upon Ms. Priyanka Roy for further proceedings. Priyanka, over to you.
Thank you, sir. Thank you for the brief introduction of the department and this university. Now, on this, I take this opportunity to give a brief introduction of our eminent guest, that is Dr. Bojan Đurin, Assistant Professor at Department of Civil Engineering, University North Varaždin, Croatia. To grace this webinar session with his presence, Dr. Bojan Đurin graduated from Geotechnical Engineering University, Zagreb in 2007, and he received his PhD degree in 2014 from the Department of Civil Engineering, Architect and Geodesy from the University of Split. He became Assistant Professor of the Department of Civil Engineering at the University of North Varaždin in 2016. He has also authored and co-authored over 100 publications. He has 13 years of scientific teaching, professional experiences in the areas of hydrotechnics. Now, on this note, I would like to invite Dr. Bojan Đurin to take this event forward with his speech. Sir, you are most welcome, sir.
Good day to everyone. Hope that you're fine. I heard about very bad situation about the COVID disease, so hope that everything is fine. First of all, thank you for such introduction, for such nice words. I hope that I haven't missed the time, because for 3 minutes there's I would say official beginning of the event, but never mind. So please take regards from Croatia, and also I would like to regard my colleague from Varaždin, which are, I would say, familiar. My future associate, Professor Surai Singh, because we are working on some stuff lately. We will speak about it. So also I would say that they are my dear colleagues and friends from my ex-university. So there's no reason for stopping the collaboration with them. And also, I believe this will be the beginning of new collaboration, especially from my colleagues which are in India. Matter of fact, this is my third event located in India, but unfortunately only by distance possibility, only online. Also, I have flight over India when I was in Thailand, so I'm very interested to visit India someday. I believe that I will, but for now, you know, the situation, and we will improvise on this way. Well, this will be everything from me. You will see my presentation. I saw and read your introduction because I have also put this in the written form. Well, it was my intention to show my ideas, my proposal, my knowledge from the not only scientific point of view, but also from the professional as well as teaching point of view, I would say, because you will see some maybe basic information about the presented topic, also ideas for the scientific research, and also some professional tasks which have been done mostly by me and my associates, because you know, science and teaching is nothing without a real case study, without application on the field, especially. Because there is one rule. If you want to be good engineer, good scientist, good professor, you have to get your hands dirty quite so when you are in water, in some channel, some rivers. This is it. All right. So I will now open my presentation. Sorry, just a moment here. I have prepared this in accordance to the given 40 minutes. This will be quite enough time for me. Hope that you are seeing my presentation, that everything is fine.
Yes, yes, sir. We can see your presentation, sir.
All right, I will turn on slideshow.
Yes, sir.
Is slideshow turned on?
So it is not presenting as a slideshow, it is just presenting as a normal slide presentation.
Is now open it in slideshow?
No, sir, it is still in the slide presentation format.
Only slide presentation, sorry. In most of the cases, usually is working.
Yes.
What about now? Is now open in the slideshow?
No.
Yes,
You have
yes,
some issues.
yes.
It's open it.
Yeah.
All right. May I start?
Yes.
All right. Now it's open. All right. And there's some microphone, yeah, but here's such usual situation when there are meetings here. So, all right, I will start. As you can see, you are familiar with the topic of today's lecture. As you know, I'm Assistant Professor Bojan Đurin. It was a very nice introduction for me. I hope this day I will become Associate Professor, because this is only on some formal tasks here at my universities, but there is a time for it. All right, and I will start make some introduction. First of all, when we are talking about some water courses, water flows, etc., you can often heard the terms large river, big river, a small river. But for some engineering comparing, what's the definition of large river, small river? Is there any strict definition about the amount of the flow, the river depth? I don't think so, but I will try to explain it. But as you can see here, if we are comparing with the rivers which have constant usual flow, which is not oftenly changed through the year, and also when you have torrential flow, so-called stream rivers, you can see a difference from the shape and from the quality point of view. So, about the torrential rivers and rivers with constant flow, can you imagine and see some problems about the flooding, for example? I have so many not so nice situation in India when big precipitation is occurring, and after that you can see such very bad pictures, not only in India but also in the Croatia. This is the one part of research here, and also regarding the sizing of the hydrotechnical facilities. For example, small hydropower plants, accumulation lakes, when you are taking into the account some flows from the river. Are there some problems about the risk, about the hazards, about uncertainty for the sizing procedures? I think they are. So, at the end of my lecture, I will try to give you the answers about it, but let's begin at some simple things. I will explain you some case study here in Croatia, and you will see that Croatia is quite small, especially Varaždin is quite small compared with India, but for our presentation, you will get quite wider picture about it. Well, here's the Croatia, my country. Here is the Varaždin, my hometown, and also the place where I'm working. And you'll see here is analyzed river Bednja. And these are here, Limnigar station, official measurement stations for the flow as well as the depth. So you can see here that Lepoglava is the most upstream river, upstream station, sorry, and the Ludbreg is the most downstream station here, and there are some also other stations between.
Sorry to interrupt, sir. Sir, we are not able to see the slides that you are changing, sir. The slides are not changing in the presentation.
Slides are not changing.
No,
no. I'm
no.
so sorry. Maybe they are not changing now. Maybe the better situation will be that I go out of this slideshow presentation and to just simply turn the slides. I'm so sorry here.
Yes, sir. That's fine, sir.
It's now better situation.
Yes, sir.
Can you see
now
this?
We can see the new slide.
Now
we can see this.
I'm really sorry. Sorry.
Okay.
Once again.
Yes, sir. Sorry.
All right.
Sorry. Yeah.
We will do a presentation on this way. But for the next time, it will be much better to get some testing, because in most of the cases it's working, sometimes is it not working. Sorry. All right. And these are Limnigar stations. Here is the observed location. You can see my country here on some smaller map, and also here on a large map. Probably you know where Croatia is. Very nice country. And this is the catchment of the river. Here is position of the river bed, and you can see here that on the upper part of the figure there is a big river Drava, which is crossing through the Varaždin and other countries, and river Bednja is tributary of the river Drava. So this is quite important to see this topic because if there are any changing of the flows, this is directly corresponding to the flow of this river, which is a big river. Right. And you will now see River Bednja. Left side is the most upstream station, and on the right side is the most downstream station. So this is very nice situation here. Everything is going very nicely without any spilling, without the flooding, and especially on the right side on this location of Lundbeck. Also, you can see from the size of the river, which is the upstream station, where is the downstream station, and so on. Please remember this left figure. And here it is. A couple of years ago, there was lots of precipitation, and usually, but not so often, you can see such pictures here. Quite unpleasant. Also, there are some trees which are growing in the riverbed, also in the entire river. You can see such trees, bushes, branches, everything is flowing, the trash, everything. And this is the one of the problem regarding the flow of such very small river. You have saw this especially in the summer period when there is no precipitation, when evaporation is quite big because of the insulation. You can walk on this river by foot simply. There is a small amount of the water, so this is, we cannot also call this the river. Right. And this is the same river on one observed location, so there is a quite big flood. There are here agriculture areas, factories, settlements, and you can see how very small river affects all human activity here. Also not so nice picture. There are very nice hills here, nice surrounding, but here is not so nice. And here is another small river, Litvica. This is also in the analyzed area. You cannot see almost anything here that is flowing. Very small amount of the water. This is it. But there was some big flood from this river. Please also remember this bridge here and also this large amount of the water. You can see how very small river could be very dangerous. Here's the mentioned bridge, the railway bridge, and also you can see lots of water which has spilled out, lots of flooding here, lots of damage, lots of cost lately because there are here agricultural land. Also, this is not very often happening, but when it happens, it's a big problem. And now here is my, I would say, some notes for the thinking and also for talking about, also for discussion, and also for the future collaboration and for the solving of very common engineering problems. At first, what are causes of such? First, precipitation. After this, of big amount of the flow. Are these climate changes? Is this human activity? I would say both of them, but I cannot tell you the right amount of any contribution. It's very hard to discuss. But in this case, what we can do, we will not waste our time for talk, and we will try to make some solution. And what are the solutions? Are there hydrotechnical regulation works, the excavators with the regulation of the river? this is also very hard question. Are there any possibilities for the legislation for forbidding the using of any human activity? This is also not a solution. We can forbid everything, but we are living around such locations. We cannot protect the river and, on the other hand, to stop our activity. Third question, which is very problematical issue here in European Union, especially when you are making proposal for funding. It's not so important if you have everything well based from the economical aspect, from all other technical aspects. There will be question, all right, are there any impacts on the environment, on the vegetation, on the flora, fauna, on everything which is living near the river, and it's not any human? This is usual question. And also, there is a last question, if regulation works are necessary. From the engineering point of view, I would say yes, they are. But there are some rules of the profession, especially from the environmental impact, which could be done that both sides are satisfied. Especially here are some small association of the so-called green activists, and they are stopping every idea, every activity due to the negative impact on the environment. I have some personal opinion about this, but I will keep for myself. Right. And you will see here example of the regulated river. So on the first side here, can we see any negative environmental impact? My opinion, maybe not yours, but my opinion is that there is not any environmental impact. Yes, this is not natural shape of the river, so-called trapezoid shape, because in the hydraulics you know all these shapes, and this is the optimum shape, all right? And you will now see also the occurrence of the big flow, which was similar to last one when the big floods were occurred. And here, there is no any spilling outside of the river. So the problem is solved quite elegantly. Here is one example of the regulation work. So this is not by hand. So these are quite maybe aggressive, maybe drastical works, but without the jig, the excavator, you cannot do anything, and you have done some regulations. Especially is quite itchy, this part of the bottom of the channel, because you're removing all the mud, all the also animal species which are small, some bugs, snakes, everything. And this is not quite popular procedure here in Croatia, but when you don't have any choice, you must do something like this. And here is maybe some art question. You can see here from the left side and from the right side which picture is nice for you. I believe most nicely is the right side, but this is my subjective opinion. Yes, because when we are talking about some art, what is nice, what is not nice, what's ugly, quite inappropriate question, maybe quite inappropriate answers. And now I'm going to the finally some real examples, what are possible solutions, and what's the point about all of these procedures, and what are possible answers on these specific tasks here. First rule is better oops than what if. It's always nice attitude if you are making your efforts to change some errors, some mistakes which have done in the past, and also if you are not trying, you cannot obtain anything. This is it. About the river modeling, there are very nice softwares, also freeware softwares, which could help you. Cats, RAS, Mike, something like this. For the river modeling, not only for the flow, velocity, but also for the sediments. This is very nice from the computer. You have your input data. You know also the rule, garbage in, garbage out. And this is very nice when you are obtaining some survey mapping, and also when you put everything into the software, you will obtain very nice presentation of the river flows. But you are in most of the cases quite limited with the input data. So now the flow measurements, at least lately, for the checking and monitoring of the flows and velocities, this is very required action. When you are doing some flow measurement in the river, no matter if the river is the big of the flow, so you can do it with ADV or ADCP instrument. All right, this is it. And also the field survey, especially this is task for the survey engineers. Later we can discuss about it. You will see some particular cases and you could have some doubt. And also about the field prospection, you cannot obtain a real measurement. Also, and some real conclusions. Also, you will have some maps, digital orthophoto, and something very nice, these applications, but you have to check them on the field. And finally, the last, there's some, I would say, procedures for the calculations, for the prediction, forecasting of the flows and depths which could occur during the time. Are there maybe some procedure for some analysis of the existing flows? They are. And I will now try to present the most common procedures and most common mistakes. There will be some critical aspect from my side, but this is my experience through my entire career. So let's start. You can see here the hydrogram of the river Begna from the Limnica station Lepoglava. So these are the average daily values of the flow because you're obtaining them to the consumption curve. And you can see here through the years they are changing. There is a time series of 20 years. You can see here big jumps, and most of the cases there are very small amounts of the flow. And what's the usual procedure when you're making some analysis? To take all of this into the Excel and to produce some linear trend automatically. This is very nice. This is quite simple, but what's the issue here? You can see here this linear line. This is the linear trend, and also you can obtain here the equation, and also there is a quite small, very, very small amount of the coefficient of determination, and also the square value. Then you will get the root. For the root, also you will obtain maybe a little bigger value, but as you know from the basic statistics, these are negligible values. But most of the scientists, experts, they are using such linear trends, and they will say, all right, the flow is rising here. It's increasing. This is not, I would say, real conclusion here. And in most of the cases when I am doing some analysis, I'm I'm trying to avoid such analysis, but in most of the hydrological projects elaborates some preliminary documentation even on the study level, on the conceptual level. This is the most common procedure, and I'm not doing such in my reports, in my documentation. And here's the same story for the same river, but on the most downstream measuring station Ludbreg, also the same situation. There are also negligible values of the coefficient of determination, and this also shows that the linear trend doesn't have justification. All right. These are some main statistic values which are going within my criticism. You can see here the average, but you can see also the large standard deviation, and by this we cannot make any conclusion about the linear trends, about some possible forecasting, what will be happen in the future. We cannot do this on previous analysis. All right. But there are some other procedures which could help us. I'm not trying now to show you everything what I know at the state of the art, because this is not intention here of this lecture. Here guests and especially students didn't come to listen to some boring professor from Croatia who will show what he knows. No, this is not my intention, but also I will try to present most common mistakes in procedures, and also to show and express my intention for collaboration and for solving of some engineering and quite scientific tasks. All right. The second very common procedure is making of correlation. Also, this is very nice. The linear trend is most commonly used, and this is very appropriate for the small amount. Here you can see coefficient of determination. It's quite bigger, so we can talk about some connection. But what's the problem here? Please, you can see here that the average daily flow of the Ludbreg is depending on the average daily flow on Lepoglava station. The idea is when you have a flow on the Lepoglava, the most upstream station, you can calculate the flow on the Ludbreg station. It's very nice because when you could detect some flow, maybe measured by hand by your measuring instrument, and also obtained by the measuring station, you can calculate what will be the flow on the Ludbreg, on the most downstream station. But is this correct? For these small amounts, there is quite negligible mistake. But for the bigger, please see, for example, one vertical. You can see here my cursor here, and here is flow about 90 cubic meters per second. And so you can see here amounts, I would say 20 cubic meters per second. And your calculation show a big difference of the 70 cubic meters per second. Is this real? Is this appropriate for some calculation? No. Let's look at other values. For the bigger flow, you will obtain small amount. So this is also questionable when you are doing some hydrological analysis. And also, some of my colleagues says, I'm not blaming them. They says, all right, this is 0.45. When we will take from this, it will be quite big value of the. In this case, it will be coefficient of regression. This is nice correlation, big connection. Yes, this is it. But you can see here that it isn't. Because statistic here is only the tool and not the primary, I would say, primary weapon only the tool which help us. And it's not good if scientists and experts are changing this order. Here is one very commonly used method, maybe not from all scientists, but from me especially. So this is so-called method where it's adjusted pressure sums by simple calculation of the value of the flow, especially doing summation. Epsilon T is the value of the flow, or any other value. It could be velocity, river depth, so on, so on. And by taking into account the average value with this line, and also by standard deviation, you can obtain these reps values and show them graphically. And what's the story about it? You're looking for the biggest peaks here. First, biggest peak. After this, you are looking for the lowest valley here, and also looking for the biggest peak, like you are driving your bicycle through the hills. And what's the now question? You have split your original time series on the sub-series. If there are some fluctuations, some deviations, jumps within the original time series, you will obtain them. This is quite a subjective method, but it helps you a lot. And here is maybe not such a hard, complicated task to obtain sub-series. The question is, what's the causes of this sub-series or such divisions of the original flow time series? This is very hard task. Are there any natural climate causes here? Are there any human activities? And such errors are obtaining, and by simply looking on the original time series, you cannot obtain and see and also detect anything like this here. The same story is for the other measurement station. You can see here overlapping the patterns of these runs. This is quite nice method because it helps you to understand what was happened in the past, and also for the some future predictions has justification. For example, you can see here that there are some sub-series in the past, and also you are going into such analysis with some precautions because of the provided analysis. All right, and now you can see here a correlation of these calculated reps values. This is not so complicated, but it helps you a lot. And what is now about the value of the squared values of the coefficient determination? It is quite big. And what tells you? It tells you that on the entire catchment, on entire length of this river between two analysts measuring stations, there are the same, I would say, fluctuations, irregularities, which are repeating and repeating. So, next task, it will be to compare all other stations between, to see are there any similar shapes, regularities. If they are, it helps us because we can obtain, I believe, similar sub-series, similar patterns. And also we will see, all right, during this time, are there any regulation works? Yeah, between this period there was, I'm talking in globally. Also, during the past, were there any big precipitations or some dry periods? Yes, yes, and also you will see that these sub-series are overlapping. All right, we will have better explanation of everything, and also for the future trends, for the future forecasting, it will help us, especially in this last period here. comparison of average daily flows here, you will see the shape, the pattern is the same, but of course, flows are bigger on the downstream station Ludwig. It's possible to predict some values by modeling, but you cannot say the computer throw me out these values, these predictions. Sorry, you can say it, but if you don't have any clue what was happening in the past, you will ask yourself, is this reliable? Are my forecasting to the future correct? And this will be quite big doubt. That was my intention regarding this computer analysis, computer work, office work, I would say. And the other side of the plate is field measurement, especially in the areas when you don't have any linear graph stations. Also, you have to have some measurement instruments. For example, this is not so cheap to obtain, some of them. And this is one analysis location for the future hydropower plant, small hydropower plant. And also we have done some, I would say, office work, like I present you. And without the field measurement, we are not quite secure if our calculations are correct, especially when you have a large area and what can you do. And that is some example. This is the radar, and here is my colleague on this bridge with electromagnetic ADV instrument. Right, never mind for this. And you will now see the same bridge, the same river, but not the same flow. And this is some extreme case. We cannot go into the river with our hand instrument. And we could come into the river, but we will not go outside because it's quite big amount of the flow, quite big velocities, and it will be very dangerous even then. So nobody will come into this river. And also, there is the situation. I have a picture a couple of days ago, the same river here. And these are some problems which occurred, and it is very hard to predict such events without the, of course, the modeling, and also without the field measurement for better comparing. And now you will see some results of the measurement, and I will ask you some questions because I would like to hear your opinion lately, maybe, and you will see some quite usual situations when you're doing your field measurement. You will see that without the interdisciplinary collaboration and other experts from the other areas, you cannot obtain real conclusions. So here is the observed bridge. Here's the measurement profile. You saw them. And we have done measurement. Here is the second profile, and here is finally the third. So three profiles. You can see here very short distance from each other. And now you will see. All right. Profile 1. Here's the amount of the flow, quite small velocities. All right. Please remember 0.82. And now we are coming on the downstream profile, second downstream profile. So here is 0.82. And now is 0.80. So the flow is decreasing. But this is not, I would say, any real situation. Because on downstream, the flow should stay the same, at least, or should be increased. But this is not situation. Why? I will explain you. And here's the third last profile. You can see here quite bigger difference. Yes, these are values of example differences between 20 liters per second and 100 liters per second. A couple of big buckets of the water. But what's the answer and what was the situation here? Any hydrological expert, hydrotechnical expert will have some doubts regarding the such differences between the flows. And what was the reason for the changing of values from the first and from the second? There were lots of changing of the depth, as you can see, and also the height of the river profile. You can see here. And this is the usual common mistake during the measurement. It could happen. These are very small values, but especially because deviations are very quite bigger, and also you can see here the amount of velocity 0.3 and here is 0.18. So this is the reason for such mirror. But on the first side, I think that most of you, and especially I would say, yes, there was some irrigation channel, maybe some tributary and water was coming out of the river. It will be wrong conclusion. And here on the profile 3, what's the reason for such big difference between 0.80 and 0.9? 100 liters per second. For such small river, this is quite big. And I would say there was some mistake in the measurement, like the first reason was, but this will not be true. Please look at this map, and here you will see, especially if you're making this enlarging, you will see one tributary, one small. So you can see now, without the survey engineer, without the GIS, without the mapping, all other disciplinaries are very, I would say, unthankful for making some calculations. So this is the point of the collaboration, especially interdisciplinary, and especially from colleagues from India, because I think that we have same experience, and especially now from the point of view of the hydrogeology, because my colleagues are surveying, and lately we will have some small discussion. My colleagues are doing survey analysis, survey research, and hydrogeology research. This is not situation here because we have intergranular aquifers. Everything is on the sand and the gravel. In the karst area of Croatia, without the hydrogeology experts, I will have the same conclusion. Also, I will conclude nothing because I don't have knowledge and expertise about it. And another problem is, you will see here, this is the limit of station Lepoglava. I will turn the video, but for some introduction, you can see on the right side, there are lots of quite bigger velocities here. You can see here splashing, and you can see that velocity is quite bigger compared with the velocity, which could be seen on the linear station. I will turn the video on. I hope it will be working. Not so nice resolution, but here you can see here. This is the linear station, and the flow is very slow, but the same amount is going on the location which is about 10 meters downstream. And such could be a wrong conclusion, because we will have a conclusion that the velocity is very low, and maybe for the at least some concept calculation about some hydrotechnical facilities, a small hydropower plant, it will be quite wrong. So you have to take into the account not only some obtained measurements, which are correct for the linear station, but also you have to go on the field and see, are there any streams here? Are there any hydrotechnical facilities here? For example, here, when embankment of the shore, embankment of the bed of this river. These are some little pearls of wisdom, but also my intention was here to mention everything, all of this, and here are my some final conclusions about it. So without connection of researchers and engineers, we cannot do anything. And this is my intention, and also some suggestions for the future collaboration, because without the survey engineers, without the GIS, without the hydrogeologists, without the civil engineers on the field of hydrotechnics, we cannot do almost anything. So you can see here also, here I am here with my student, measurement of the river flow, but this ADCP is not appropriate for some small amount, but is quite appropriate for a big river. This is one channel, derivation channel from the hydropower plant of the river Drava, the big river here in our part of Croatia, which is flowing through my hometown Varaždin. And also these two mentioned rivers, Big and Plitvica, they are tributaries of this big river. And here's the old city of the Varaždin. You can see here that this is 1/4 of the entire city, so about 50,000 inhabitants, quite small compared with the settlements in India. But here is everything from my side. Hope that I was not too long and maybe quite extensive in my explanations, but here it is. I would like to hear your opinion, comments, your criticism, everything. Especially, I would like to hear if there are some suggestions for collaboration, because Professor Surai and my associates, we have established some preliminary, I would say, ideas and some preliminary collaboration. And I think that it will be better and better to the each. Thank you very much.
Thank you very much, sir. This is Dr. Varun this side. Thanks for such a nice presentation, and it was very interesting lecture. Sir, we have few questions from the participants. So, sir, I would like to take a few of the questions because we have received several questions. So the first question is that which is considered as the most important parameter that control the flow velocity of a river?
Maybe it will be more appropriate to say parameters. Parameters, not parameter. Parameters, maybe, because there are many of them. About the flow, of course, flow depends on the velocity. And velocity depends, of course, about the cross-profile section of the river and the inclination of the riverbed. And inclination of the river at the bottom of the river is most of the cases, because there are turbulent state of the flow, is parallel with the face of the river. So this is it, especially the type of the embankment. Is it natural? It is by concrete, by stones in the concrete, and so on, so on. these are the parameters which affects on the velocity and as well as on the flow.
Thank you, sir. Thanks. So the next question is that how the digging of the sediments can change the water flow. Is there any effect of the digging of sediments on water flow in the rivers?
Yes, but on such small river, I would say not drastically. On a big river, like it was last one show, the river Drava. Yes, in this case, sediments have quite big impact. On such small rivers, no, because water is splashing this and impact is negligible, very small. And also, it is very hard to obtain the amount of the deposits with such measurement device, with the ADV. But the ADCP, you can obtain such because it's changing through the time, because there are quite big amount of the flow and also quite big amount of all sediments in the river. Yes, this is answer to your question. Hope it is fine that you are satisfied.
Thank you, sir. The next question is from Pranay. He wants to know, is there temperature can be considered as a controlling factor for the water flow in the non-glaciated regions?
Some controlling sector, you mean on limnigraph stations? Yes, if you're meaning on some control flow, locations, because you are obtaining the values from each day. Of course, you know that the river level is changing through the day, but defining of the consumption curve, you are calculating the flows, and for each hour you will obtain average, and this will be average daily flow. These are the input values which are obtained by Croatian hydrometeorological department or the service. Unfortunately, in Croatia, such stations, such control points are quite limited because of the very small number of them. And for some continued measurements, you will also have to get maybe more of them, but it's quite expensive here because you have to build this, you have to secure monitoring, protection of the depths, and especially from the long time period, this is quite expensive. Yes, there are control points, and for some other points, you don't have anything else than to go into the river if you have measurement instrument, and this is the only possible solution.
Thank you, sir. So the last question is from my side also. So can we consider the flow of water in a torrential rivers as a flash flood? Can we consider it as a flash flood?
If I have considered it like, I didn't understand you.
Sorry, sir.
Please, can you write in the chat? I didn't understand the last part of
it. Sir, I would like to ask that can we consider the excessive flow of water in torrential rivers as a flash flood? Can we consider it as a flash flood at the time?
Yes. Sorry, sorry, I didn't understand. As a fast flow or
flash flood? Flash flood.
I don't get it. The term. Please, can you write it in the chat? Maybe it will be much more easy for me.
Sir, my voice is clear to you?
Flash flow.
Flash flood. Yeah. I'm talking about flash.
You mean on the rising of the peak of the hydrogram? Flash flood, the very quick spilling out of the river, or the you mean on the wave, occurrence of the wave? And if you mean on this is very unthankful task. It's very hard also to predict them, to calculate, and also quite hard to measure him, because usually you will obtain, you also could have from some stations here in Croatia. I don't know the situation in India, but from the some locations in Croatia, you can see changing of the river flow as well as the changing of the river bed for each hour at the moment. You can watch how the water is rising. But in the most cases, it's quite too late, because if you can see the basic of the water level, and especially if it is quite big, it's better to prepare for some flooding, to rabbit bags for some improvised solutions, to prepare some pumps if there are some settlements here. For flash flooding, it's very hard task here, because it depends on the all tributaries, depends on the precipitation. It's very hard to model. All right, and there are some questions. Sorry, I can give answers. How can analyze underground water runoff? Regarding this, I'm not dealing with underground water. This is not my preliminary part. But from the analysis of the hydrogram, you know the basic two parts in general of the hydrogram. When you are splitting hydrogram, you have some also rules how you can split. So underground water you can get from the hydrogram, from the shape you are making, dividing of them, and the upper part is from the river flow, and other bottom part of your subsection is underground water runoff. This is very, I would say, unprecisely population. But for the first impression, you can obtain them. This is maybe the question as colleague Sayan Akur sent me. And can you calculate lag time using geographic information system? My answer is that I do not know, because I'm not doing it like this, but here my colleague from my side, especially here are experts here from your side, especially Professor Surai Singh, which deals with something, and that was, I would say, one lack of my knowledge, because I'm not dealing with this. But as I have made contact with the Professor Surai, and also I have one colleague from my side which is also interested from collaboration, I think that it is them to give you the answer. And also here is my other colleague, Miss Dragana, who is dealing from hydrogeological part of research, and these three disciplines or these three research area will give the answer to all of this question. I'm so sorry that I cannot give you the answer on lag time. I can only show from my logical point of view. I can see this high length changing of the flow on the Linegraph station, and also from the measurement in the river. Only this, but from the other side, unfortunately, I cannot give you answer on this.
Thanks a lot, sir. Thank you very much, sir. It was such a nice and informative presentation on river flow dynamics, especially in case of torrential rivers. So now I would like to call upon Mrs. Priyanka Roy for further proceedings. Priyanka.
Thank you, sir. Thank you. This was a very informative presentation, sir, and a very good round of question and answers. Now, on this note, I would like to invite Dr. Suraj Kumar Singh for the vote of thanks. Sir?
Yeah. A very good afternoon to all the participants, and especially to Dr. Bojan Đurin. It was a very informative session where we had a lot of insights about the various river modelings, various impacts of climate change, then environmental impacts on flood dynamics, where he correlated the various parameters related to climate change dynamics, its flow modeling, and different kinds of river modeling that you have to perform. You have to have a correlation, you have to see the statistical findings, what are the errors, where are the errors that has to be rectified prior to coming to a solution. He also enlightened in detail about the interdisciplinary research whenever you're dealing with a flood, because the flood is a natural as well as a man-made features. So there you have to involve a hydrogeologist, a GIS engineer, a civil engineer, a surveyor. A multidisciplinary approach has to be applied final to a conclusion. He also highlighted the emphasis of hydrograms and different statisticals and hydrogeomorphological modeling, the use of GIS and remote sensing that nowadays each and every human being or the person who is working on disasters need this technology, because it provides a synoptic overview with a multidisciplinary approach can be applied, as well as various statistical analysis and the various thematic maps can be brought into a single dimension using the use of GIS. So it was a very enlightening session by Dr. Bojan Đurin, that during this pandemic he has taken out his precious time and he has enlightened us with his thought, what he has experienced in Croatia. From Center for Climate Change, on behalf of Suresh Gyan Vihar University, I would like to have further collaboration in terms of river modeling, hydrographic analysis, drainage morphometric analysis, use of GIS and GPS technology for the various hydrological analysis. And with this, we come to the end of our one-day webinar. Thanks to Dr. Varun, Dr. Shruti, Dr. Pranay, Ms. Priyanka, Mr. Rishabh, to make this event a grand success. And finally, to all the participants who have been benefited from this enlightened talk. May I request all the participants to please turn on their cameras so that we can have a group photography.